Hi, welcome back to my channel. My name is Gina. In the last video, we derived 4 kinematic equations for motion under constant acceleration. And in this video, we are going to look at 2 examples for motion in a straight line, one horizontal and one vertical. Let's do a quick recap. So the 4 kinematic equations that we derived in the last video is final velocity equals initial velocity plus acceleration times delta t. We got this equation by calculating the area under acceleration graph to get the change in velocity. And the second equation, similarly to the first equation, but for the second equation, we calculate the area under curve in the velocity graph to find the delta x, which equals to the initial velocity times delta t plus half times acceleration times delta t. Then we isolate for delta t and acceleration from the first equation and substitute them separately into the second equation to get the third and the fourth kinematic equation. The third equation is final velocity squared equals initial velocity squared plus 2 times acceleration times delta x. And the fourth equation is delta x equals half times initial velocity plus final velocity times delta t. Now let's look at the first example. A car accelerates uniformly from 10 meters per second to 45 meters per second in 3 seconds. We want to find the acceleration of the car and the distance traveled. Let's write down the knowns and the unknowns. We have the initial velocity, which is 10 meters per second. And the final velocity is 45 meters per second. We also have the delta t, which is 3 seconds. And the unknowns are the acceleration and the distance traveled, delta x. Let's start with the acceleration. So we want to use an equation that has acceleration and the other 3 knowns we have, the initial velocity, final velocity, and the delta t. So we can look at the 4 equations and found that the first equation, it has final velocity, initial velocity, acceleration, and delta t. So the only unknown in equation 1 is the acceleration. So let's use equation 1. Final velocity equals initial velocity plus acceleration times delta t. We substitute the knowns we have. Final velocity is 45 equals initial velocity, which is 10, plus acceleration times delta t, which is 3. Now we can isolate for the acceleration. 3a equals 45 minus 10, that is 35. So acceleration is 35 over 3, and the unit is meter per second squared. Now let's find the distance traveled. And since the direction of the car does not change during the 3 seconds, so delta x, the displacement, also equals to the distance traveled. Now let's look at the equations. We want to use an equation that has delta x, which is equation 2, 3, or 4. You can use either one. Here I'm going to use equation 4. Delta x equals half times initial velocity plus final velocity times delta t. We substitute the knowns. Half times initial velocity is 10 plus the final velocity, which is 45, times delta t, which is 3, which is 3 over 2 times 10 plus 45, that is 55. So the distance traveled is 82.5 meters. Now let's look at the second example. In this example, the motion is vertically. You throw a ball upward from 1.5 meters high at 5 meters per second. What is the velocity of the ball when it hits the ground? First, let's write down the knowns from the question. We know the initial position, yi, is 1.5 meters. Since you are throwing the ball from 1.5 meters high. And the final position, yf. We want to find the velocity when it hits the ground, so the final position is 0 meters. We also know the initial velocity, which is 5 meters per second. And the final velocity is unknown. That is what we want to find. And we also know the acceleration. For vertical motion, if there is no other forces acting on the object, then the acceleration is the gravitational constant and is pointing downward. And since we define upward as positive, so the acceleration here is negative 9.8 meters per second squared. Now let's look at the four equations. We want to use an equation that has the final velocity. And we don't have delta t as known, so we can eliminate equation 1, 2, and 4. So let's use equation 3. Final velocity squared equals initial velocity squared plus 2 times acceleration times delta y. We substitute the knowns. Initial velocity is 5, so 5 squared plus 2 times acceleration, which is negative 9.8, times delta y. And delta y is final position minus initial position. That is 0 minus 1.5, which equals to 25 plus 29.4. That is 54.4. And we know that the final velocity would be negative since the ball is going downward. So we want to take the square root of that with a negative in front. Square root of 54.4, which equals to negative 7.38, and the unit for velocity is meter per second. And that's the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.